we've been able to solve missing side lengths and missing angles when dealing with right triangles only. However, there are triangles out there that are not right triangles. These are called oblique triangles. An oblique triangle is just a triangle that does not have a right angle. Couple things to note for notation. Angles are always written with capital letters. So this is angle A, and directly across from that would be considered side A. Angle B, directly across would be side B. And then angle C, directly across from side C. Everybody good? Okay, they'll write side lengths as like non-capital letters. We're going to learn today how to solve oblique triangles using the law of sines. So here's one thing to note. To solve an oblique triangle, we must have at least one side, and then we can have any other two parts, but we have to have at least one side. And then any other two parts, and we can go through and solve it. Now, there are times when you'll use the law of sines, and there are times when you'll use the law of cosines. Today, we're learning the law of sines. So here's the first case when you'll use the law of sines. If we have two angles and one given side, we will be able to use the law of sines. Now, think about it, guys. If you're ever given two angles inside a triangle, you can always find the third angle by subtracting it from those two from 180, right? So if you have two angles, you can always find a third angle, so then you could use the law of sines. Now, second, if you're given two sides and an angle, as long as the angle is across from one of the given sides, notice, then you can use the law of sines. So once again, if you're given two sides and just one angle, you won't be able to find this angle and this angle quickly, but you will be able to go through and solve this as long as the given angle is across from one of the given sides. Now, the nice thing is you're going to see once you understand the law of sines, you won't have to have this memorized because you'll just go for it. And if you try to set up the law of sines and you can't, you won't have enough information. So then you'll use the law of cosines. So you won't even have to memorize when to use it. Like, I don't even talk about this in regular because they'll try to set up the law of sines and not have enough information. So then they use the law of cosines. Does that make sense? Okay, here we go. Here is the law of sines, everybody. So write it down. Sine of angle A over side A will be equal to the ratio of sine of angle B over side B, which will be equal to the ratio of sine of angle C over side C. Now we can also reciprocate that and instead put our sides on top. A over sine of angle A equals side B over sine of angle B equals side C over sine of angle C. Now, there are times when you'd want to put sine of the angle on top and times when you'd want to put the side on top. It all depends on what you're trying to solve. So if you're trying to find the angle, you're going to want it on top, like let's say our x was here, because then the algebra will be prettier, because what you're trying to solve for would be on top of the equation, if that makes sense. So if we were trying to find side A, we'll want to put sides on top so that what we're solving for is already on top. So it just makes your algebra come out better. You can still do it if you set it up wrong. It's just the algebra will be a little bit more intense. So notice the law of sines is sine of the angle divided by the side across from it equals sine of the angle divided by the side across from it, right? Has to be that order. We're not going to use all three ever. You would only ever set up two, like say that, or those two, or these two. You would never have three equations. You'd have one equation. So just a note. Okay, now here is why the law of sines works. So I might ask you, why does the law of sines work? So let's say you didn't know the law of sines. If you were an advanced thinker, you would go about solving these triangles in the way I'm about to show you. So why does the law of sines work? So I'll show you. So everybody, if I go to angle C and drop down an altitude or a height here, I now have two separated right triangles. Here's triangle number 1 and here's triangle number 2, both right triangles. Now, if I'm talking the law of sines, it's obviously using sines, right? Law of sines has sines in it. So let's set up a true statement with sines. So here's angle A. Sine of angle A is equal to opposite over hypotenuse. So my true statement is sine of angle A is equal to opposite over hypotenuse. Does everybody see how that's a true statement? Yeah. And then over here, look at angle B here. Opposite hypotenuse. So now I could also say sine of angle B is equal to opposite over hypotenuse. Now look, the height equals the height on both of these. So in both of these, the height is the same. So let's solve for h in both cases, and then we can set them equal. Because if h equals this and h equals this, then they're equal to each other since the heights are the same. So I'd multiply both sides by b. I'd multiply both sides by a. And now do you see h and h equal those things? So now I can set each of those equal because h equals h. So my true statement is b sine of angle a will be equal to a sine of angle b. And then what did they do to finally get law signs? What did they do, guys? Divided by a and b, right? They got all the b's on one side, all the a's on one side. Wait to see that. Thank you. So they divided by a to both sides, and they divided by b to both sides. So then over here, a's are gone, b's are gone. And look, there's the law sign. So the law signs allows us to skip this long process and jump right to it, but I might ask you to give me why the law of signs works, because it does take a little teeny bit of thinking. Okay, here we go. So here's my first example. Find all the missing parts here. So first of all, notice we have two angles and a side. So we can find that third angle really easily. I want you, if I ever ask you to solve the triangle, make a box of answers. So let's go through and find angle A. Everybody grab a calculator because if we all wait for each other to calculate it, it takes too long. So we would do 180 minus that, and what's my angle here? Yeah, 102.3, and then 28.7. Okay, awesome. We just found angle A is 49 degrees. So look, I made my little box here. Angle A. So now let's go ahead and solve for either side will work. We could solve for side C or side A. I'm just going to put an A. So let's set this up. Let's put sides on top since we're trying to find a side. So we'd say A over sine of the angle across from that side will be equal to the ratio of this side. You've got to stay consistent. We're putting sides on top. 27.4 divided by sine of the angle that's across from that side. And now look, you only have one unknown, A. So solve for A, just using algebra. So we would multiply both sides by sine of 49. Now because these are degrees we're inputting, your calculator would need to be in degree mode. So go ahead and look, A is alone, so type it in. 27.4 sine of 49 divided by sine of 28.7. So then we know side A is equal to, everyone should hurry and calculate it. Cool. And then this is a good way for us to reference how many decimals. Depending on what they did, do the same thing. So we'll call it 43.1. All right, let's find side C. So you'd go like this. C over sine of the angle across from it is equal to, now you could use any side and angle. I'm just going to go with this again. 27.4 over sine of the angle across from it. So now you would multiply up by sine of 102.3, and we're all typing it in as quick as possible, and C's alone now. 55.7. Now keep in mind, a lot of people will get here, and then they'll use the Pythagorean theorem to find the third side. That does not work, because this is not a right triangle. Do not use Pythagorean theorem unless it's a right triangle. Okay, cool. Everybody good? Pretty easy, yeah? Okay, I want you to look at this problem and go ahead and do it by yourselves. It says, I'll just read it to you, then you can go for it. It says a pole tilts towards the sun at an 8-degree angle away from the vertical. This is one to make note of because on the test it never fails that people cannot draw this correctly. I'm not going to give you a picture, I'm going to want you to draw it. So it says that it tilts at an 8-degree angle from the vertical. Now vertical is straight up and down, so this is 90 degrees. It says it casts a shadow that's 22 feet long, and the angle of elevation from the ground to the top of the pole is 43 degrees. How tall is the pole? So we're going to put an X here. So see if you can figure out how tall the pole is. Now, I had somebody ask a really great question last hour. They said, well, how do you know if the sun is over here or over here? Because it said 8 degrees from the vertical. So they were like saying, that was a really good question, because they were saying like, couldn't 8 degrees be this way? Do you get what I'm saying? So here's what somebody else, I didn't even think of this. I'm like, oh, you know, they'll give you more information. Not true. Somebody's like, no, think about it, Miss Christensen. If it's casting a shadow, the sun has to be over here. Just think about it. If the sun is shining on something, it's going to cast a shadow that way. You see what I'm saying? So then if it's leaning 8 degrees from the shadow, it says, from the vertical, and cast a shadow, the sun's over here is what I'm saying. Because it's casting the shadow that way, the sun has to be over here. Okay, cool. Ready to go. I'm going to save that for the video. So once again, because of the wording, it says it tilts towards the sun. We would put the sun in and then tilt it backwards. Why are you laughing at that?
Oh, because you do that just...
So you really just have a triangle here that looks like this. That must be 98 degrees. And then we have our x, and then 43 and 22. So now we can find this angle here, which is what? What? 39. Thank you. And now we can set up our true statement. We would say x over sine of 43 equals 22 over sine of 39. And then you'd multiply up by sine of 43. What is the height? 80. What is it? 8? What is it? 23.8. 23.8 feet long is that pole. Awesome stuff. Easy? Okay, cool. Now, looking at this one, this is my last one before, well, pretty much before lunch. So it says find the missing sides and angles. So I want you to notice something. We don't have 2 angles. We only have 1 angle. We do have 2 sides. And notice, remember, one of the rules is for the law of sines to work, the angle has to be across from one of the given sides. And it is, so we're good to go. So now we could not find angle C because we don't have side C. However, we could first find angle B. So I would make a little box of solutions. Angle B is what we're finding first. Now, the algebra is going to come out differently here. Watch. So everybody, wouldn't it be like this? Sine of angle B. We're going to put that on top this time. Do you see why? Divided by the side across from it, which is 12, will be equal to sine of, we got to stay consistent. This time we're putting the signs on top. Sine of angle 42 all over the side across from it, which is 22. So now to get B alone, we would first do what? This algebra. Yeah, what would we do, Tanner Papke? Algebra. Yes, multiply both sides by 12. You're awesome. So sine of angle B is equal to 12 sine of 42. That's a parenthesis. 42 divided by 22. Now everybody tell me, what would be the next step to get B alone? Yes, sine inverse. It's trapped inside. The only way to undo it is sine inverse. Math doesn't change, guys. So B, angle B, is equal to, this is how the ACT would leave it, sine inverse of all that stuff. That's how the ACT would leave it. We would write it like that, and then go ahead and type into your calculator that. Making sure it's in degree mode since we're finding an angle, a degree measure. Angle B is ... Thank you. 21.4 degrees. So now, angle B, we've got that, 21.4 degrees. Now we go like this. Angle C is 180 minus that, minus that. Yeah. Uh-huh. Oh, yeah, they might go through and actually divide those 12 and 22. Hey, how about, what do we get? Thank you. 116.6 degrees. And now look, to find side C, we're going to set up the law of sine. So here we go. We'd say, okay, I'm going to hurry and write that in. 116.6. So now we would say side C over sine of 116.6 will equal, we could do either side. I'm going to go with the given. So it's equal to, we got to stay consistent, 22 divided by sine of 42. So with this one, you'd multiply up by sine of 116.6. And then side C is what? 9.4. You're awesome. Okay, awesome, good to go. Okay, so what I want you to do next is, that is the hardest part of the law of science. We have learned the law of science. Now, in secondary 3 regular, we would be done. However, we have a lot more to consider in honors because there are times, guys, when your picture is actually deceiving. The question is, if they give you information to create a triangle, can you even create a triangle? Is it really a triangle? Does a triangle exist? If not, then you can't create it. If you can't create a triangle, you can't solve it. So that's your first question. Does a triangle exist? And if it does exist, how many triangles? Is there 1, 2? How many triangles? So you have to consider a lot more when dealing with triangles. So what I want you to do is there's a red string on your desk. This is going to give you a visual aid. I have taught this in previous years without it, and it confused people. They can see it a lot better. So first hour we didn't do the string. Second hour we did, and it made a lot more sense to people. They were like, I can now visualize it. I'm good to go. So everybody grab a string and tape it, the same as I have it taped up here. I want you to make this true, everybody. You have a height. You have side A, swinging side. It can swing around. You have side B. I want you to make a string so that A is shorter than B, like literally. So go make that true. And also make side A also shorter than the height. So you can remove your tape if you need to, everybody, at the top. So ready? Make that true on your tape. Sorry. So everybody, this is the final answer here. All of these. So if A is longer than or equal to B, it's going to come down, because if you think about it, longer than or equal to, so it's going to click and hit somewhere right there, creating an acute triangle. So right here, it's longer than H, so if I dropped it straight down, it's going to come down here, right? So if we take it down, if we take this string down, so A is now right here, this is A. Then if we swing it backwards, it hits right there. You see how I always start down at the bottom and work backwards? And if I swing it, it's obviously going to cross right here if it's shorter than B. So we have that triangle. And we have our first triangle, which was like this. If you need to take a picture of that, you can. If you're understanding it, seeing it is the big thing, because I don't like to memorize this. I think about it. Here we go. So, does this triangle exist? If so, let's find the missing sides. Here we go. So, guys, let me show you how I set it up. Now, understand something. It's not always going to be set up as A, B, and C. You're only swinging the side that's across from the given angle. Do you understand what I'm saying? You are going to be given two sides at an angle. You're going to swing the side that's across from the angle. So look back here. We were only given 42 degrees, and we were given this side and this side. This would have been the swinging side. Okay, here we go. So let's see if this triangle exists. This is how I draw it out. I'm not going to be drawing it to scale. I go like this. We don't know if it's going to connect. Let's see if it does. So that's how I start out. I'm going to call this angle A, and this is my swinging side, side A. So this is 12. This is 20.5. I always set it up just the way we use the strings to make my swinging look the same. And then this is side B, so let's call it 31. Now guys, think a little bit. If I literally took this red line, which is my string, my red string, and swung it over, it's definitely going to cross somewhere like up here, right? If it's 12 and that's 31, we know it's going to cross right there, right? Now the question is, with the height, what is that length so that we can draw this more accurately? So the first thing you're going to do is have to push pause, and on this right triangle, you're going to have to find the actual length of the height to know if it exists or not. So let's go off to the side. So you'd say, okay, here's theta, opposite hypotenuse. So we would say sine of 20.5 is equal to my opposite, h, over my hypotenuse, which is 31. So now our height is what length? 31 sine of 20.5. So everybody, what is the actual length of our height? Thank you. Okay. 10.8. So now what do we know? I'm going to now go like this and say that our string is now orange to drop it down better. Isn't that, if this is 12, our string isn't going to cross down here, everybody, compared to the 10.8? If I drop down the string on straight onto my altitude, do you see how it's going to be down here? So now let's work backwards. Let's make our triangle. So if we keep swinging this way, boom, there's my first click. Does that make sense now? Boom. So I go off to the side and I draw the first triangle I found. It was A, C, B. This was 12. This is 31. This is 20.5. Now I'm starting down here. It's coming and it's obviously cutting short, so it's going to click again right there. So now we have our second triangle, which is obtuse. This is still angle C. This is still angle B right here. So now we have this triangle. A, B, C. This is still a 31. This is still a 12. And this angle A is the same as that angle A, 20.5. So now we have to ask ourselves two triangles, even though we were not told we had two triangles. Does that help? Okay, now let's go ahead and on the first triangle here, we can set up the law of sines. Let's find these angle B's. So let's start, I don't know, here. So we would say sine of angle B over the side across from it is equal to sine of angle 20.5 divided by the side across from it. So then angle B will be equal to sine inverse of 31 sine of 20.5. I'm doing the algebra in my head. Is anyone mad about me skipping the algebra in my head? Okay, so type it in and tell me what angle you get. $64.8 degrees. Okay, now everybody, should that be this angle B or this angle B? Think about it. The smaller one. Guys, it's a Q. Isn't 64 a Q? Isn't this obtuse? Leaning outside of 90. So it would not make sense to make that a 64.8 degrees. So that must have been this angle B. 64.8 degrees. Okay, well now I can continue solving because now I can find angle C and so on. Well then how do I find this angle B? I'm going to point something out to you. If I have an XY chart here and I draw this acute triangle right here. Okay, we're going to call this angle B. Right here, angle B. So I have some acute triangle, and this is the 20.5. Okay, now isn't it also true? Sorry, I didn't draw that right. Let me draw this in. Right there's my obtuse angle. They've got to share the same angle A. So, but this right here is the 64.8. So that is, it's just this one's turned around backwards. This big triangle right here, they are sharing the same one. Wait. I'm not saying that right. Let me change colors. So guys, everybody look, do you see this point right here? That shares, this XY point on this triangle has the same XY point, right? So now to find this obtuse one, we would do 180 minus 64.8. Okay, cool. So now we know this angle B, 115.2. And now we can continue to solve. Is everybody understanding it? Because you're all just talking instead of like listening. So, are we good? So now you can continue solving, right? You could find angle C in both cases, and then you could go through and solve the rest. Do you want me to continue or move on? So my question for you is this. How many triangles exist, if any? Ready, go. Figure it out on your own. Tell me. Once again. Here, now let's think about, okay, so you guys said there was two. So you went like this, and you said this is angle A, so this is side A, this is side B. So then you found the height. What was the height? 8.6. So now you know that this right here, if I was to lay it straight down, would be right there. So it would then come and click there. So I would go like this. A. And then you would do 9, 10. And that's all right here is 60 degrees. So then right here is 60 degrees. There's your acute triangle, right? And then if you were to go, you're right, starting right down here. And then if you were to click there, there's your other one. So this is angle A, this is 60, this is 10, this is 9. Now, if you think about it, why is it that when we go through and solve this using the law, if we find this, we do in the end sine inverse, don't we? So why is that always going to give us the acute angle? Well, because sine inverse's outputs are between pi halves and negative pi halves, right? So that makes sense of why your calculator always gives you the acute answer. So then once you know the acute answer, to find this, you would do 180 minus that. Because once again, if you have an acute triangle, there's the obtuse, there's the acute. Everybody good? Yeah? Okay, cool. How many triangles exist, if any, go? Try again. Did we find the height? 5. Okay, now then that means if we were to take this and lay it straight down, it's going to be crossing in that exact spot. So our one right triangle is all we have, right? So we could even use Pythagorean theorem and not use the law of sines and all this good stuff. Okay, awesome. That is literally the oh, wait, I thought it was the end. Okay, last thing we have to learn is how to find the area of a non-right triangle. So, this is how you're going to hear me say it. It's actually really easy. So, area of a right triangle is 1/2 times base times height. That's where this formula actually is derived from, is that formula. If you want to know how they got this formula, it's on page 434. You can go look and see for yourself. We don't have time. Okay, so here's the formula. If you're given 2 sides and an angle in between, you can find the area. It's just 1/2 times side 1 times side 2 times by sine of the angle in between those 2 sides. It does have to be the angle between the 2 sides. Has to be. Yeah, good. Yeah, if you have 3 sides and 1 angle, you can do any 2 sides and it will come out the same answer. Yeah, great. So if we have side A and B, we would need to use C. Great. So that is really it. So let's look at an example. Oh, look at this. Find the area. It's not a right triangle. We have 2 sides and an angle in between. So you'd say our area is going to be 1/2 times side 1 times side 2 times by sine of the angle in between. And you would just type it directly into your calculator. 2. Are you just saying stuff?
No, I didn't. I said the whole decimal.
And then also, let's say this is a centimeter and a centimeter, everybody. Then a centimeter times a centimeter would be square centimeters. Now that's literally like square centimeters, like filling this in. Okay, cool. All good? Now, here's the thing though. That was easy. What if you're given this picture and they say find the area? Well, first of all, you cannot use this information because it has to be the angle in between. So you say, I need this angle right here, but I can't find that angle if I don't have that side, right? So I want to hurry and say, well, I can find this angle. I'm going to call it frowny face angle because you have to find that first. So let's set this up. That's an angle. So we would say sine of frowny face over the side across from it equals sine of 25 over the side across from it. Solve for frowny face. So you would have frowny face is equal to sine inverse of 3 sine of 25 divided by 10. What's it? Frowny face? Like what? Okay, 7.2. So now we are good. We can now find this angle which we need to find the area. 180 minus that minus that. So now we could do area is equal to 1/2 times side 1 times side 2 times by sine of the angle in between. And now you just type it into our calculator. Easy? Awesome. So if you need to take a string home and really explore how I went over the side links and rewatch the video, it's kind of hard though, the string part's not on it. But go home and explore the different ways. Did you all take a picture of the different cases? Do you want it? Okay, cool. If you need to take a string home, you can. I'll come back to that page in a minute. It is on the, it's 6-9.